Hello guys and welcome back to this one. Today we're going to be looking at a very interesting one. And what are we going to be looking at today? We're going to be looking at something called max heap. So basically we are trying to find the max stack, right? And we're going to be looking at why does this work? And basically we are looking at a stack and we are trying to return the O of we're trying to return the maximum value in that stack at an O of 1. So let's just read the question. I think everything becomes clearer. It says, design a stack that supports a max operation, which returns the maximum value stored in the stack and throws an exception if the stack is empty. Assume elements are comparable. All operation must be O of 1. If the stack contains n elements, you can use O of n space in addition to what is required for the element themselves. Now, it now goes ahead to say this problem. So we'll try to break down the problem. We say this problem basically stipulates we need a max, we need the max value as O of one. We throws an exception if the stack is empty, assumes elements are comparable, and all operations must be O of 1, right? So that's pop, append, getMax, and peak at the head of the stack should be of 1. And then I believe in the addition to is a static process adds adds to that process but does not affect time or space complexity. Yeah. So it's a process that like that maybe all this other stuff that we build on, like say what would we have here? Let's say the max value here, right? The holder for it, so it doesn't basically necessarily affect complexity, but it's just it's just there. So I believe in addition to, so basically I'm talking about this in addition to what is required of the element themselves. It's like values that don't necessarily affect complexity in a sense. And yeah, so let's look at the brute force. Say in the brute force, we are going to do the no-brainer. Basically, and iterate over the stack to get the max. So for this episode now, that's what we're going to be focusing on. It's going to be the no-brainer approach, where we obviously go through the stack and get the values for. So for this set, we are going to be. So for the brute force approach, we are going to be doing the no-brainer approach. It says in the brute force, we are going to do the no-brainer and iterate over the stack to get max. Now, class max API stack says so basically what that says or what that means is that just as we know we want everything as O of 1 in the optimized state, in this brute force state, and that's what we are going to be focusing on in this episode. We are just going to have maybe an array, and then what's going to happen is that every time we do that array, we are going to segment it and basically get the values from it, in the sense of like iterating over it and picking out the maximum value from it. And that's what we are going to be looking at as we do the brute force, and then we look at the O of n, or the complexity of the brute force. Now we call the instantiation of our class, right? And we instantiate it over here. Then we write the dot pop function that basically if it is none, if it's not empty, if it's empty, let's return that it's empty. That, but if it is not empty, then we pop we then pop the last value from the stack, right? And then we then go ahead to say define append this thing. So basically we are defining our append function, and then we just basically append the value to it. And yeah, that's just that for that. Then we say getMax. So basically we are trying to get the maximum value, and then we hold maximum value as index of as 0, and then we iterate over the whole stack and then find max value as it increases. So max value is going to be checking max value and the number that we are going to be at, and then the highest max value will be returned. The peak we will look at basically the last index of the stack, and that's it. And so we will see that when we run this, we are going to get this in. We are going to get the what's it called. So we see our 10 value appear here, and that's the maximum value of this this list over here. And then we do, and then we could see that there. So we could see that append is append is going to be O of 1, right? Complexity. Okay, is O of 1. So append is going to be O of 1. Pop O of 1 still in the brute force. GetMax. Now this is where we have issues. We have O of n because we have to go through the entire list searching, right? And then peak is O of 1 though, because it's just checking the last value, and we can find that by using what we used over there, which is checking the last value. Muchas gracias. Auf Wiedersehen. Tschüss.